Hey, Christina.
Hey, Susan.
We're on the last unit, aren't we? And we are going to do linear regressions.
Linear correlation and regression.
Yes.
Yeah. So, so the first thing usually that we do if we want to see if there is a linear correlation.
Which means.
Actually, let me scroll down to the definition.
Oh, let's do that.
Yeah. Yeah.
Let's go out of order. What do you say?
Yeah.
Okay.
Okay, so a linear correlation is the measure of a relationship between two random variables.
It's the measure of the linear relationship.
Yes, the linear relationship. There can be other kinds of correlations that are not linear, but we're only looking at linear.
So we're only looking at lines, people.
Yeah. And so a data set, which is a set of ordered pairs, all right,
like an XY.
XY, yeah, so ordered pairs.
Okay.
Has a positive linear correlation if Y increases as X increases. So I'm talking about like these pictures over here.
Oh, yeah, where it kind of slopes up.
Exactly. And so the line of best fit, like if I drew, a line of best fit.
Wait a minute, that line doesn't include all the points.
It doesn't. It's just an estimate.
True.
It's just an estimate.
Yes.
But that line would have...
Point that out.
Thank you. But that line would have a positive slope.
It does. Yes.
Right. And so we say...
Because it's heading up.
Yeah. Whereas, if I drew a line with a positive slope over here...
Oh, yeah.
That's not a good estimate, right?
That is not a good estimate because those points are heading down as you go across.
Yep, exactly. So that would be a negative linear correlation, right?
Oh, let's mark the negative ones then.
Yeah, so...
That is probably not the line of best fit for those points. What do you think?
It's pretty close. It would have a negative slope, though.
Yes.
Yeah.
Yeah.
But these, these scatter plots over here, I would say have a negative correlation.
Mm-hmm.
Right?
Because as you go across, as X gets larger, Y is actually getting smaller.
Yeah. Good.
Okay.
And that correlation coefficient, okay, right?
Mm-hmm.
That is, that's what we use as a numerical measure of the correlation.
Yes.
And if the slope is negative and it has a negative linear correlation, then it would have a negative R value correlation coefficient.
Okay.
Yeah.
Are we going to come back to this and talk about different R's?
Yeah,
Okay.
We can do that. Yeah, we'll probably do that in the lecture notes.
Fine, whatever. I wanted to talk about it now, but okay.
Oh, do you want to?
No.
Okay. All right. Well, we have examples of R values down here.
Yes, we do.
We have examples of R values down here.
Yeah. And as R gets closer to 0, like negative 0.3 or positive 0.3, which is pretty close to 0, it's a really scattered line.
Yeah.
Whether R is positive or whether R is negative, if it's really close to 0. But R can't be larger than 1, can it?
No.
Or negative 1.
Right. So an R value of positive 1 would be a perfectly straight line with a positive slope.
Which ain't going to happen in real world data.
Right. But the closer I get to 1, the better the correlation is, but the stronger that relationship is between the variables.
Yeah, we can definitely say it's probably a line if it's lining up like that, closer to 1, or closer to negative 1.
Right.
Would be just a straight set of points that line up in a straight line with a negative slope.
Yep. Exactly.
Okay.
Yeah. So our hypothesis test that we're going to do later will basically tell us, are we close enough to 1 or negative 1 that we have a significant correlation?
That's exactly what we're going to look for. Yeah.
But for this pre-class video, let's go back up here for a moment.
Let's do.
All right.
We kind of got off track, didn't we?
We did a little bit.
Sorry.
That's okay. But now we can answer this question.
Ooh.
Right? So this question says, would the following scatter plot have a positive or negative correlation?
Okay, you write down what you think on your paper. We're waiting. And now we're going to talk about it.
Yeah. So I would say that red line that is drawn there, okay?
The line of best fit.
The line of best fit has a positive slope because as X increases, Y increases.
Yep, it's just heading up as you go across. Yep.
Yeah. So if that line has a positive slope, then that means that I have a positive linear correlation.
Yes. Now, we don't know what R equals on this one, do we? It doesn't
No.
show it, does it? We don't know what R equals, but we know that R is positive.
Yes. Yep.
Because the slope is positive.
Yep.
Okay.
Good. So speaking of slope,
Speaking of,
let's think about linear equations and where the slope is in the equation.
yes, because the way you learned it in algebra is probably not going to be the way it's written in statistics.
Yeah, not the way it's written exactly,
Yes.
but it's still,
Yes.
you know, because
Yes.
in algebra, you probably saw a slope-intercept form of a line, y equals mx plus b,
Okay.
right? Where m is your slope and b is your y-intercept.
Which is where the line crosses the y-axis.
Right.
Yeah.
So in statistics, we still use a linear equation for what we call the regression equation, which is
Yeah.
the line of best fit. So line of best fit. Okay. But usually how we will write that is y hat, a predicted value of y, equals...
Because it's based on a sample.
b sub 0 plus b sub 1 times x. Okay?
Yeah.
And that's just, I don't know, that's just the way
Yes.
the notation is in most statistics textbooks.
But it means the same thing.
Yeah, but notice here that whatever is with your x value is your slope.
Can we mark it up in the algebra one as well?
Yes.
Yeah. There we go.
So that b sub 1 is like my m. All right, that's my slope. Because regardless of whether I'm looking at the algebra type equation or the statistics type equation, whatever the coefficient of x is has to be my slope. And then that b sub 0 would be my y-intercept.
Okay. So we're going to look at these equations and identify the slope and the y-intercept. What are we going to do with these?
We're going to determine whether the slope and the y-intercept are positive or negative.
Okay.
Okay. So, let's look at the first one here. What is my slope?
Okay, the slope is the coefficient with x. So that would be 1.14.
Right. And that would be positive.
Yeah. Positive slope. Because of that plus in front of it there.
Right.
Okay.
So I know that if that were a line of best fit, I would know that they would have a positive correlation.
R would be positive.
Right.
Okay.
And then my y-intercept is?
Negative 98.23.
Right. And that would be negative. Okay.
Okay.
All right.
But we really care much more about the slope than we do the intercept.
Yeah, we do. We care more about the slope than the intercept. But when you're given those values, on StatCrunch for the regression equation, it's important to write it out correctly. Like write out the coefficient of the x with the x. And,
yes, please.
Yeah, not mix those up.
Right.
Yeah. So what's my slope here in the second
Okay,
one?
well, I see x, and this time x is paired with, is multiplied by negative 98.23.
Right. And
So that must be my slope. So it is a negative slope. So R would be negative. My correlation coefficient would be negative.
Right. And the y-intercept
is positive 1.14.
Okay. How about the next one? What's my slope?
I see negative 1.14 paired with x, or multiplying x. Yeah.
Right. Negative 1.14.
So that's a negative, so R would be negative.
And that y-intercept would be?
I can't read it.
Positive 98.23.
Sorry, raised my glasses up for just a second, and then I couldn't see it.
Good. Okay, and then the last one, you probably got the hang of this by now.
Yeah.
With my x, I have 98.23, so that would be a positive slope, a positive correlation. And the y-intercept would be negative 1.14. So that'd be Okay, good. And that's basically what's on your 4.1 pre-class quiz. So you should be able to answer those questions.
Okie doke.
Awesome. Oh.